Hi, this is Joe from the Math Perimeter, where I help to make mathematics accessible, engaging, and approachable through various forms of content, including articles, infographics, videos, and email newsletters. This video is part one of a three-part series where I cover advanced uses of the substitution rule. For more information about this topic, please refer to the article linked in the description. In this video, we will evaluate the integral of e to the x plus e to the x dx, the integral of tangent of x dx, and the integral of secant of x dx. We first evaluate the integral of e to the x plus e to the x dx. We begin by using exponent rules to obtain the integral of e to the x times e to the x dx. We now let u equals e to the x. Our differential is then du equals e to the x dx. Substituting into the integral, we obtain the integral of e to the u du. Integrating, we get e to the u plus c. Back substituting, we arrive at a final answer of e to the x plus c. Next, we evaluate the integral of tangent of x dx. Using the quotient identity gives the integral of sine of x over cosine of x dx. Now we let u equals cosine of x. Our differential is then du equals minus sine of x dx. Multiplying both sides of the differential by -1 gives us minus du equals sine of x dx. Substituting into the integral then gives the integral of -1 over u du. Applying the constant multiple rule gives minus the integral of 1 over u du. Integrating gives minus ln absolute value of u plus c. Applying logarithmic properties then gives ln absolute value of u to the -1 plus c. Applying exponential identities then gives ln of 1 over the absolute value of u plus c, which is equivalent to ln of the absolute value of 1 over u plus c. Back substituting then gives ln absolute value of 1 over cosine of x plus c. Applying the reciprocal identity, we arrive at a final answer of ln of absolute value of secant of x plus c. Lastly, we evaluate the integral of secant of x dx. We begin by multiplying the numerator and the denominator by secant of x plus tangent of x. This gives us the integral of secant of x times secant of x plus tangent of x all over secant of x plus tangent of x dx. Distributing the secant in the numerator then gives us the integral of secant squared of x plus secant of x tangent of x all over secant of x plus tangent of x dx. Now we let u equals secant of x plus tangent of x. Our differential is then du equals secant of x tangent of x plus secant squared of x times dx. Substituting into the integral gives us the integral of 1 over u du. Integrating, we obtain ln absolute value of u plus c. Back substituting, we arrive at a final answer of ln absolute value of secant of x plus tangent of x plus c. Thank you for watching. I hope you enjoyed the video. Please like and subscribe. Thank you. See you next time.